Okay, so let's get into this. What I wanted us to do this evening was just have a little bit of a discussion about some of the definitions that we come across in probability, because I think, trying to understand the words and what they mean is also an important part. Okay, so the first thing that we're going to do is have a look at some diagrams and then decide which of the statements they've given us apply to that particular Venn diagram. So they've given us statement A, where it's one of our probability rules. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B, where the probability of A and B does not equal 0. So what does that mean? What is the probability of A and B does not equal 0? What does that mean for us? What are they telling us when they say this? Anyone got any idea? There we go. Good. Well done. So some of you are saying one thing and others are saying it in a different way. So Shisana says not mutually exclusive. Yes. Nolatanda, the circles intersect. Yes. Seth, they overlap. Yes to all of you. Okay. So in other words, the circles overlap and there's something in that intersection. Okay. So there's something in our intersection. All right. So they are not mutually exclusive. Good. Well done. Aha, event A and B may take place at the same time. Lovely, Leetlu. That's a very nice way of putting it. Okay, so A and B can take place at the same time. So statement B is identical to statement A, except they say that the probability of A and B equals 0. So what can we say about that? If the probability of A and B equals 0, what does that mean for us? They do not occur at the same time. Quite right. So A and B are mutually exclusive. In other words, they cannot happen at the same time. So in other words, you can't be in grade 11 and in grade 12 at the same time. Okay, you can only be in one grade, okay, at a time. Then they've given us some more statements. So the probability of A or B equals 1, or the probability of A or B does not equal 1. Then in E, the probability of A plus the probability of B equals 1. Then we see another word, the word complementary. So what does it mean when events are complementary? What does it mean when the events are complementary? It's a bit of a more difficult one to explain. All right, so if you have a look at Venn diagram D, everybody, there we would see an example of complementary events. Okay, so what I could say is that the complement of A, whatever is not A is B, and whatever is not B is A. So they would be complementary events. So that's also true, Cindy. There we go, in Kaniso, quite right. So the probability of A plus the probability of not A is 1. Yes. So Cindy, you've just rearranged that and you said the probability of A is the probability, is 1 minus not A. Good, you're both correct. You both said the same thing in different ways. Lovely. Okay, so yes, iPhone 2. So all the elements in the sample space are either contained in A or they're contained inside B. Yeah, absolutely. So the difference, yeah, that's also a nice way of putting it, Lihu. So the complement of A is everything that isn't A, 100%. So if we have a look at diagram B, everything that isn't A would mean that we would color in all of this. Okay. Whatever isn't A is everything outside of A. All right. But the 3 is not inside B. So we can't say that B is the complement of A. Okay, because we've got that 3 sitting on the outside. Whereas if we have a look at diagram D, all right, everything that isn't A is B. Okay, because there's absolutely nothing that's sitting on the outside. So here we could definitely describe the complement of A as B in this case. For D, for B, the complement of A is not B. Okay, because there's something on the outside as well. But you're quite right. Everything that is not A has been colored in yellow in diagram B, and that includes the 3 on the outside. Okay, so for example, okay, so that's what we mean when we use the word complementary. We don't use the word inclusive. So that's an old word. What they mean by inclusive in this case, so the definition of G, they mean not mutually exclusive. So things are either mutually exclusive or not mutually exclusive. It's just like when we say they're independent or we say they are not independent. Okay, so let's just have a look at which of these statements apply to these Venn diagrams. All right, so in the case of Venn diagram A, so this one over here, which of the statements could we apply? Could we apply A or B? Which one would be true? Would A be true or would B be true? Okay, so it's not B, okay, because for event B, well, so not event B, but for statement B, the events have to be mutually exclusive. In diagram A and B are not mutually exclusive. So here we would have to say A, yes, 100%. So we could say A. What else could we say? What else would work? That's fine. And can you so yes, so A works. So B is not going to work, right? What about C or D or E? Okay, so Jude sent me a suggestion. What do the rest of you think? No, they can't be complementary. Okay, so remember, for them to be complementary, they have to be mutually exclusive. D, that's right. Yes, good. So D will work. Statement D works. Does statement E work, Oratile? Oratile is saying, what about statement E? Does statement E work? Does statement E work in this case? Okay, so for statement E to work, the probability of A is 3 and 7. That's the probability of A. Then the probability of B is 1, 2, 3, 4, and 7. So I think the only other thing that I would say here would be G. For this one. Okay, that they are not mutually exclusive. Okay, let's have a look at the next one. Right, so we redescribe these as using A or B. Would we say they're not mutually exclusive, or would we say that they are mutually exclusive? So there's no intersection here. They are mutually exclusive. Yes, quite right. So we would say B, good. What else would we say? Well, the definitely probability of A or B does not equal 1, so we could definitely say D for this one as well. Someone said H. Yes, they're mutually exclusive. Good job. Well done. Okay, they're not complementary because the complement of A is not B. And the complement of B is not A because of the 3 on the outside. So they're not complementary. The only event here that's complementary is going to be D. D is going to be complementary. Let's have a look at C. So what can we say about C? Are they mutually exclusive or not mutually exclusive? I would say they are not mutually exclusive because we've got that area of intersection. I agree. Someone else says G will apply here. Yes, quite right. A and G apply. Is there anything else that applies in this situation? The probability of A or B. So the probability of A or B would be 1. So we could definitely say C for this one as well. Because to calculate the probability of A or B, we'd say the probability of A plus the probability of B minus the probability of A and B. So the probability of A occurring is 3 and 6. The probability of B occurring is 4 and 6 minus 1 and 6. Okay, so that would give us 6 out of 6, which would give us 1. So we could say C here as well. Okay. D, no. So D and C are opposites of one another. So we can't say C and D for that diagram. It's just C. Okay, for the writing on the pink right-hand side here. Okay, now for the last one for D, there's a few things that we should say. Well, first of all, they are mutually exclusive, so we could definitely use B. Okay, the probability of A or B equals 1, because that's 3 and 6 plus 3 and 6, which would be 6 out of 6, so we could say that. The probability of A plus the probability of B would also be equal to 1 for this. If they're also complementary. And we could also say H, they are mutually exclusive as well. Okay, are there any questions before we move on? Sure. Okay, so in this question over here, there are 6 numbers, right? So that's why you've got 6 in the denominator. So you've got 4 things that are B, the 3, the 4, the 5, and the 6. Okay, so that's why it's a 4 in 6 chance. Does that make sense? All right. Yes, I can explain the idea behind complementary again. Right, so the only events that you can see on the screen that are complementary is going to be in diagram D. Okay, so the complement of A is B and the complement of B is A. So everything that isn't A is B and everything that isn't B is inside A. So that's why A and B are complementary events. All right, so in diagram B, A is not the complement of B. Okay, or should I say, no, that's correct. The complement of A, everything that isn't A is not just what's inside B, because you've also got something outside of B in the sample space, which is that 3. So in other words, for something to be complementary, the events need to be mutually exclusive, and everything, even and all the events, all the values need to either be inside the one event or inside the other one. Okay, so that's the idea behind complementary events. Okay, the word and means both at the same time. The word or means one or the other or both. So if I say A and B, let's say we're looking at diagram A. Let's look at diagram A. A and B is this that I've shaded in orange. That's A and B. It's both at the same time. If I say A or B, it means what's inside A. So everything that is inside A, everything that is inside B, as well as that, but that's in both. So A or B would be the 1, the 2, the 3, the 4, the 5, and the 6. Okay, so in this situation here, A or B is 1, the 2, the 3, the 4, the 5, and the 6. A and B is only the 3. Does that make more sense to you? Who was asking? Let me just check here in the chat. Okay, Lichlu. Okay, does that make a little bit more sense to you now?
Hello, ma'am.
Hello, Tegofatso.
Ma'am, I have a question, ma'am. Does the
sum, go for it.
Does the sum formula work for both mutually exclusive and not mutually exclusive?
Yes, yes. So you can use this formula here the sum formula, as you were saying, this one here, you can use that for mutually exclusive and not mutually exclusive events. The only difference is that if events are mutually exclusive, this is going to be equal to 0.
Okay.
Okay.
Yes.
Yeah, but both of those will work for events that are either mutually exclusive or not mutually exclusive, 100%. Okay. All right, let's go on and have a look at something else. So in this example here, we are considering a 6-sided die. It's rolled and the number of dots landing face up is noted. Consider the following events. Now they give us 3 events. Event A is a number less than 3. Event B are even numbers, and event C is the number 4. The first thing that they ask us is, what is the sample space? So they want us to list all of the values in our sample space. How would we do that? You're right, Oratile, there are 6 values here, but we would set it out like this. Our sample space goes from 1, 2, 3, 4, 5, 6. That's our sample space. There we go. Now they want us to determine the probability of A, the probability of B, and the probability of C. Okay, so let's do the probability of A first. What do you guys think the probability of A should be? Okay, so iPhone 2 says 3 out of 6. Menentle says 2 out of 6. Chloe says 2 out of 6. Agreed. Okay, so out of the numbers 1, 2, 3, 4, 5, 6, the only numbers that are less than 3 are 1 and 2. So that's 2 out of 6 numbers. Okay, so we would write that as 1 over 3. Good, well done. The probability of B occurring. Now remember, those are the even numbers. We don't include 3 iPhone 2 because it says less than 3. It doesn't say less than or equal to 3. Okay, good. Yes, quite right, guys. 3 out of 6 numbers are even. The 2, the 4, and the 6. So that would be 3 in 6 or half. Cool. Let's do the probability of C now. Oh, there's a whole bunch of you that answered this one. Oh, wow. Yes, there we go. Well done. Yes, perfect. You're all correct. Oh, 1 in 6 chance because it's just the number 4. So that would be 1 in 6. Good. All right. So that's that done. That's that done. Okay, now they say determine the probability of A prime. What does that mean? What does question C mean? And how would we calculate it? Does anybody know? Not A. Good. The probability of A not occurring. Right. So to calculate the probability of A not occurring, it would be 1 minus the probability of A occurring, like so. So because we know what this is, we know that it's a third. So here we would end up with 2/3. Okay, so A and not A are complementary events. Okay, because it's going to add up to 1. Okay, Then they've said, are the events mutually exclusive? So we need to compare each one with the other, all right? So in D, we can say, are A and B mutually exclusive? So A and B, are they mutually exclusive? Sure, Mbalente, I'll go back. Okay, everybody, I'm just going back to Mbalente. What did you not understand? Ma'am, can you please explain the probability of C? You didn't get it. Okay, so Mbalente, C is just the number 4. So it's just this. Okay, so that's why it's 1 in 6. Okay, because only one number is a 4. Okay. All right. So back again. Are A and B mutually exclusive? No, they're not mutually exclusive because they share the number 2. Okay, 2 is even and it is less than 3. So A and B is not equal to 0. Okay, because 2 is in there. All right, so they are not mutually exclusive. So A and B are not mutually exclusive. Okay, what about A and C? Are A and C mutually exclusive? What do you guys think? Are A and C mutually exclusive? Yes, they are. Okay, because 4 is not a number that is less than 3. So A and B are mutually exclusive. Well done. And now let's compare B and C with each other. So what about B and C? Are they mutually exclusive? No, they're not. Okay, because 4 is an even number. So B and C are not mutually exclusive. Okay. All right. Now they want us to determine the probability of A or C. So in question E, they want the probability of A or C occurring. Remember, A and C are mutually exclusive. So for events that are mutually exclusive, the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. But remember, for events that are mutually exclusive, this probability of A and B, this is equal to 0 for events that are mutually exclusive. So A or B is the probability of A plus the probability of B. So that would be 1 in 3 plus the probability of C occurring was 1 in 6. Okay, so that would give us 3 out of 6, which is 1 out of 2. The other way, of course, we can look at that is that if we go up here and have a look, okay, the probability of A was those 2. The probability of C was that one. Okay, so A or C would have been the numbers 1, 2, and 4. Okay, now for part F. Let's just move this other question down out the way. So now they want us to determine the probability of A or B. A or B. What we could do here, I suppose, is we could draw ourselves a Venn diagram just with events A and B in it. Remember, we said A and B are not mutually exclusive. So that means that A and B, look, that is a terrible circle. Let's just try that again. So that means that A and B have to have an area of overlap. Okay, because they are not mutually exclusive, right? Okay, so there's event A, there's event B. Remember, event A was a number less than 3. Okay, so 1 is going to go here, but 2 is even as well. So 2 has to go in the intersection. 3 is neither less than 3, nor is it even. So 3 is going to go outside. 4 is even, so it goes in B only. 5 is neither A nor B, so it's going outside. And 6 is going to be B only. So not worrying about event C here, because the question says A or B. Okay, so remember A or B means A or B or both. Okay, A or B or both. So in the case of question F, the probability of A or B is going to be 1, 2, 3, 4 out of 6, which is 2 out of 3. Does that make sense to everybody? Are there any questions? Are we all okay with question F? Okay, what did you not understand, iPhone? Okay, so Orotile, why didn't I put in 3? Because 3 is not less than 3 and it's not even. So it's not A and it's not B. So it can't go in to either event A or event B. Chloe?
Hi, ma'am.
Hi, Chloe.
Would we have to draw a Venn diagram? Like, could we not use the formula that's above?
You can. You could do that. You could use the formula. That's not a problem. Yeah, I just thought it'd be easier for you guys to understand if I drew a Venn diagram, but you don't have to have the Venn diagram if you don't want to. That's not a problem. Okay, so I'm not sure who it was, but somebody was saying that they didn't understand where the 4 and 6 came from. Okay, so there are 4 values that are either A or B or both. The 1, the 2, the 4, and the 6 are either in A or in B, or they are A and B. Okay, so remember, A or B means A or B or both A and B. That's what A or B means. Okay, so A or C is the same thing. It means A or C or both A and C. Sure. So probability of A or B is going to be the probability of A minus the probability of B, sorry, plus the probability of B minus the probability of A and B. So we know what the probability of A is, right? From the beginning over here, we know that it's 1 in 3. Sorry. Yes, 1 in 3. We know what the probability of B is. It is 1 in 2. And we know that the only thing that is both A and B is the number 2. So that's 1 in 6. All right, so now we need lowest common denominators. So we're going to times that by 2, and that by 2, and that by 3, and that by 3. So that's going to give us 2 out of 6 plus 3 out of 6 minus 1 out of 6. So that gives us 5 out of 6 minus 1 out of 6. And that's where the 4 out of 6, which is 2 out of 3, comes from. Okay, there we go. No problem. So I've done it using the formula. So you can either look at the Venn diagram or you can work with the formula. Okay, does that make sense to everybody? Any questions about that? Yeah, the Venn diagram is easier. I agree, so. Okay, but if you want to do it using the rules, it's not a problem. Okay, now let's go and have a look at the last thing. And I am going to spend a bit more time talking about this on Thursday. Today I wanted to concentrate on tree diagrams as well. So I want to do that, an example with a tree diagram after this. The other thing that we learn in grade 11 is independent events. So we've got this rule that we've seen in grade 10 and again in grade 11. But when they start talking about events being independent, that is purely grade 11 work. So for events to be independent, for events to be independent, we would say that the probability of, let's use A and B in this case, would be equal to the probability of A times the probability of B. Okay, so that is, you won't get less marks. No, you won't. You won't. So here they've said events B and C. Are events B and C independent? So let me just change that. So we cannot start out assuming that this is true. I cannot write this on the page. I have to do a left-hand side and a right-hand side. It's like doing an identity, right? So the first thing that I need to do is work out the probability of B and C. And I can also write that like this, intersection C. Okay, means the same thing. So what is B and C? So remember, B is even numbers, C is 4. So what is the probability of B and C? What is B and C? This is so if you want, I can draw another Venn diagram. Maybe that's easier. Okay, let me just scooch over. So let's draw a diagram for B and C. So there's B and there's C. Okay, so B is the even numbers and C is the number 4. So 4 is going to go here 2 and 6 are going to go here, and 1 and 3 and 5 are on the outside, okay, because they are not B or C. So probability of B and C is your intersection. So there's only one number there, it's the number 4. So that's why this is 1 in 6. The probability of B occurring is 1, 2, 3 and 6. We know that already, or a half. Times the probability of C occurring. Sorry, let me just set this out a little bit better, sorry. The event C occurring is 1 in 6. And when we multiply fractions, we'd obviously just do it on our calculators, but we'd get 1 times 1 is 1, over 2 times 6 would be 12. So the left-hand side does not equal the right-hand side. 1 in 6 is not the same as 1 in 12. So we would conclude that. We would say, therefore, the probability of B and C does not equal the probability of B times the probability of C. Therefore, B and C are not independent events. Okay, does that make sense to everyone? Are there any questions? Good. Okay, so we'll talk about this in two-way tables or contingency tables. We'll do that on Thursday. Was Cindy all okay? What I wanted us to do now, right, was go and have a look at a tree diagram. Okay, because this is something that could definitely come up in your trials or in your finals. Okay, they normally include either a tree diagram or a Venn diagram for us to answer on the grade 11 work. Okay. I was hoping we we're going to get to that, but I'm not sure that we will. Let's just move this down. And let's go back to this example over here. All right, so they tell us that there are 30 dogs and 25 cats at a pet shop. Okay, Ayola's just asking me a question. I'm just going back. How you got the answer for B and C again? So B and C is the area of intersection, isn't it? B and C is this. This is B and C here. Okay, so there's only one number there. One number out of the 6 possible numbers fits into that area. Okay, so that's why the probability of B and C is 1 in 6. Okay. Are you happy with that? There we go. All right. So the first thing that they ask us to do is calculate the probability that the first pet chosen is going to be a dog. How would we calculate that based on the information we've been given? There are 30 dogs, 25 cats. The owner chooses an individual pet at random. What's the probability that the first pet chosen is a dog? So remember, it's what we want, how many dogs out of the total number of pets. So the probability of choosing a dog is going to be there we go. 30 over 55. Good, well done. Okay, and then we would obviously just have to simplify our answer. Okay, so 30 out of 55 gives us a 6 in 11 chance. Okay, good, well done, perfect. Now in part B, they want us to draw a tree diagram. Now, if they ask you to do this, it is a little bit of a mission. And unfortunately, there is no sort of easier way to get around it, okay? So the situation in this case means we're choosing, well, this owner is choosing 3 pets. So our first choice would be a dog or a cat. That would be 1 pet. Second pet, again, could be a dog or a cat. That's the second event in green. And the third time that the owner chooses a pet, again, there is a choice of either a dog or a cat each time. When they say to us, indicate on your diagram all possible outcomes, they want you to go along the branches. So if we go along the topmost branch, we would have chosen a dog followed by another dog, followed by another dog. Or we could have chosen, so there'll be 8, 1, 2, 3, you can count them at the end here, 1, 2, 3, 4, 5, 6, 7, 8. So then you could list the 8 outcomes here. So then it would be dog, dog, cat, or dog, cat, dog, or dog, cat, cat. Okay, and then choosing a cat first, then a dog followed by another dog, or cat, dog, cat. How many have I got? 1, 2, 3, 4, 5, 6. We're on the last branch now. So cat, cat, dog, or cat, cat, cat. Okay. The other thing that they would expect us to be able to do is calculate the probabilities going along the branches. So let's say we want to calculate the probability of choosing a dog and then another dog and then another dog. All right. Remember, we said that there are 55 pets in total, 30 plus 25. 30 of them are dogs, 25 of them are cats. So the first time you choose a dog, you have got, as we discussed, a 30 in 55 chance of choosing an animal. The second time we choose a pet, there's 1 less dog and 1 less pet. So there's a 29 in 54 chance now of choosing a dog the second time. And the third time that the dog is chosen, there's 1 less dog and 1 less pet. So there would be a 28 in 53 chance of choosing a dog. So to calculate the probability of choosing a dog followed by another dog followed by another dog, we would multiply the probabilities together as we go along the branches. So it would be 30 in 55 times 29 in 54 times 28 in 53 chance, for example. Okay, so that means, so I'm just working this out. You guys can do the same. Oh, goodness me, what am I doing? That looks absolutely dreadful. Sorry, I was writing nonsense on my calculator. Okay, so I'm getting 812 out of 5247. for example. Okay, I mean, that's not one of the questions they asked us. I'm just doing that as an example with you. So the one that they do actually want us to calculate, all right, is here in question C, is dog, cat, dog in that order. So I'll let you guys do that. What is dog, cat, dog in that order? What would you get for dog, cat, dog? Anyone got an answer? No, you got to go along the branches, Amahle. So the chance, so it's this one here, dog, cat, dog. Okay, Orachile. Okay, Bali, Miss Cindy. Okay, so a lot of you have got very different answers. Actually, no, hang on a second. iPhone 2 and Sihawu and Mbali, you all got the same. So choosing the first dog, we know we've got a 30 in 55 chance. A cat hasn't been chosen yet. There are 25 cats. There's one less pet. Choosing another dog, there's 29 dogs left, and there are 53 pets. Okay, so we would do it like that. So 30 over 55 times 25 over 54 times 29 over 53. Okay, so I'm getting 725 out of 5247. That's it. All right, let's do one more. Let's answer question D. Maybe this will be a little bit easier for you guys. Shame, this is obviously quite difficult. No. So remember, it said dog, cat, dog in that order. Okay, so let's do cat, cat, cat. And then we'll leave it there. What's the probability of choosing a cat, followed by another cat, followed by another cat? Let's see how that one goes. And then you do.
Yeah, because I saw them carrying without my pole.
Okay, all right. I tell you what. Let me do this with them, and then you can do your poll, and we can say goodbye.
Okay.
Okay, so 25 cats, guys, 55 pets. One less cat, one less pet. One less cat, that's a 3. One less pet. Okay, just like that. There we go. Correct. So 460 out of 5247. There we go.